Hello everyone, this is John from Civil Center. Welcome to our channel. As we know, Civil Center is continuously working with the vision to guide civil engineering student and professional. And for that, we keep making videos on different software and on different topics related to civil engineering field. And I have also started a series on how you can read a structural drawing properly. So in this series, whatever the things that we have covered so far, so first we have studied about the different components of the structural drawing. Then we get to know about the notes, and then we have studied in detail about the title box. Now in the last live session, we have also covered the plinth beam schedule, the plinth beam layout, and also the longitudinal section of the plinth beam. In today's session, we will discuss about the roof beam. So what are the different things that are there in the roof beam? So a cantilever beam is something extra. Okay, so sorry, the concealed beam is something extra for the roof beams, and we will discuss about all the things in detail in today's live session. Now, if some of you has not seen the previous videos yet, then I will add the link of those sessions in the description and you can easily watch that. And by the end of this live session, I'm going to have an important announcement for all of you, so stay tuned till the last minute of this session. Okay, so every minute will be useful for you, that's my guarantee. Okay, now we will go directly to the structural drawing that we were discussing since the last two live sessions, and we are going to start that now. Okay, so here is my screen, and viewers, if you are having any kind of question, then you can simply write that question in the comment section and I will definitely answer all of them. Okay, so let's see if we have any viewers so far. So right now we don't have any viewers. So viewers, as you join the session, you can start asking your questions. In the middle of this live session, I will keep checking for the comments, so you can simply ask that. And if you are new to this channel, then you can also subscribe to this channel and press the bell icon, so that whenever I am coming live on YouTube or whenever our team is uploading any video on any special topic, then you can be notified. And if you will find this live session interesting and informative at the same time, then you can simply like this session and you can also share it with your friends and colleagues. So let's have a brief introduction about what we have covered. So we have already completed this plinth beam layout in the last live session, and in this plinth beam we have studied about the center line diagram and what is the distance in the center lines, why it is being taken from A to B and A to C, then A to D. So why we have to follow this sequence like that? All these things have been answered in the last live session. So if you have not watched that, then you can watch it after this one. Okay, so we have discussed about the column positions, and now let's relate this plinth beam layout with the typical beam column layout over here. So you can see all the center lines are almost same, but we have also a few new lines over here. Okay, why so? Because you can see in the horizontal direction we have the same numbers of the center line, but in the vertical directions you will find two additional center lines over here. Now why these two additional center lines are present over here, that we will discuss just in few minutes. Then the columns will be same as it were on the plinth beam until and unless you have any floating column. So from the viewers, I would like to know what is floating columns. So in this project we have not used the floating columns, but if you are looking at a drawing like this and you are finding any particular column absent in the plinth beam layout and that column is present in the beam column layout, then you can understand that that's because of the presence of the floating columns over here. Okay, so let's see how many viewers have joined. So we have 3 viewers right now, and viewers, you are free to ask any kind of question in this live session, and obviously you can answer what is floating column. Okay, so Next, what we have this beam arrangement over here. Now in the last live session I have told you why the beams are arranged in this way. So I have told you that the beams are present wherever we have the walls, and these beams are taking the loads of the walls. Okay, now there is one additional type of beam in our beam column layout, and this beam is known as conceal beam. So by the time I am explaining all the things, I would like to ask from the viewers, what is conceal beams? So far you have two questions for you. What is floating column? And the second question is, what is conceal beam? And I am waiting for your answers in the comment sections. So viewers, do answer that. Okay, now, and don't worry if you don't have the answer, because in some time I will also give you the answer for that. Okay, so you can see over here we have these center lines, and we have taken the measurement from A to B, then A to C, and not from A to B and B to C. And this is done to maintain the accuracy while doing the construction, so that if you are making any error while marking any footing or any of the column, then you can just not repeat the mistake to the next column or the footing. Okay, so to avoid such mistakes, we have to go with this pattern of measurement. Okay, so this is to maintain the accuracy. Now we have different types of the columns over here, and we, from the column schedule, we know that we have these 5 types of columns. Okay, so guys, I think this is quite clear because I have explained all these things in the previous session also. Now what is new thing over here? We have the conceal beam over here, and because of this new conceal beam in our structural drawing, we had to draw another center line. And since we are drawing another center line, we will not go with the previous names over here, so we will rename all the center lines. Like previously, this center line 2 was the center line 1 in case of the plinth beam, so we can go for the renaming so that we can easily do the measurements, and that's why we have additional center lines in the beam column layout. Okay, so because of the presence of the conceal beams, this happened. Now why these conceal beams has to be provided? So there is a simple answer for that, and what is that? These conceal beams will take the loads of the walls. Okay, and what kind of walls? So over here you can see this is taking the load of the balcony walls. So these are just lighter walls. So at some places you will find that this is a concrete wall. In the balcony also, like you can find the brick walls, and then in the balcony you can also find some kind of handrails, like they can be of the iron or they can be of the steel. So steel is in demand these days, but there are also people who are going for the brick walls and also for the iron handrails. Okay, so these are lighter over here, and these are not extending till the complete floor, so they are having a height of almost 3 feet to 3.5 feet. Okay, so they are lighter in weight, and we don't need an actual beam over there. So for that we are going for the conceal beam over here. Okay, okay. So Rohit Khanna is asking about my number. So my number is present over here in the description, Rohit. You can contact me through this number. Okay, so this is my number, and you can simply register yourself to this Google form also. So if you will just register over here, okay, the registration link for our live classes is this one, then I will personally give you a call on this one. Okay, so you can also simply register yourself over here. Next we have Jakir Ali, and he is saying that hidden beams are called conceal beams. Okay, so that is a correct answer. So now the question is how we can hide any beam. Okay, and answer is there in the beam column schedule. Okay, so we will just go to the schedule of beams over here, and we will look at the depth of the conceal beams. So over here you can see we have the concealed beam of dimension 250 by 100. So that means this 100 is the thickness of the concealed beam, and what it shows, it shows that this depth of the beam is equal to the depth of the slab. Okay, so that's why it is not visible, and so it is also known as hidden beams. So that's why you can see we call these beams as a concealed beams. Means if your slab is of thickness 150, then you can go for a concealed beams of thickness 150 okay, so the basic concept is the thickness of the you can say the depth of the beam is equal to the thickness of the slab, and such beams are not visible, so they can be known as hidden or the concealed beams. Okay, so that's the correct answer, Zakir Ali. Next, guys, if you are finding this session useful, then you can hit the like button, okay, because that will motivate me a lot to come up with such informative videos. So there are 9 viewers watching right now, so guys, you can simply hit the like button over here. Okay, thank you. Next, what we have over here, so we can see that in our beam column layout we have new beams over here, and mostly these beams are the concealed beams. And over here one more thing is to be noticed, we have this cross sign over here. This is showing the no slab is present over here, that means the slab is absent over here. And this is a portion of the staircase, so in the portion of the staircase and lifts you will find this sign, which means slab is absent in this portion. So this is the way how to study the beam column layout. Okay, and all the portions where we don't have any cross sign, in all those portions we have the slab present. Now we can see one more thing over here, we have cut out a section AA over here, and this is a section for the slab. So you can see we have a two-way slab over here, and this is a sign of two-way slab. Okay, and this is a sign of one-way slab. Okay, so there are basically two types of the slab that is being used in this beam column layout. Okay, so you can also go for the signs of the slab, and we will talk about in detail about the slabs when we will discuss about it. Okay, so right now we will stick to the beam column layout and we will discuss about the beams and the columns. So the column has already been described. Now let's go to the schedule of the roof beam. So concealed beam size has been explained. Now let's take an example of beam B1. Okay, and by the time let's check the comments also. So guys, if you are having any kind of question, you can simply ask that question in the comment section, and if you are like finding this video informative, then please hit the like button. Okay, next we have this beam B1, and over here you can see we have the size of 250 by 350, and we have three types of reinforcement over here. First one is the continuous reinforcement, then the second one is our extra reinforcement, and the third one is our shear reinforcement. Okay, so in the continuous reinforcement we have top and the bottom, that is reinforcement is present in the top and the bottom. That means we have to go for 2 bars of 16 mm dia all through, and at the top, and 2 bars of 12 mm dia all through at the bottom. So these are the main reinforcements. Then comes the extra reinforcements. These reinforcement, that means the extra one, are not provided for the complete length of the beam. They are restricted to a particular distance, and how much distance they are restricted, that we will see from this image. Okay, now we will also learn about that one, but let's stick to the extra reinforcement over here. So you can see at the start, end and center we have this extra reinforcement, and then comes the shear reinforcement. So these are the rings that you can see in the beams. So technically we call those rings as stirrups in case of beam. And my question is, what are those rings called in case of columns? So for the beams they are called as stirrups. Now let's see if we have any kind of question from any of the viewer. So viewer, I think we have the continuous viewers over here, but I'm not seeing any likes over here. So do hit the like button so that I can stay motivated during this live session. Okay, that is the bare minimum that you can do from your side. Thank you. Next, and you can also answer me, what are the rings called in case of columns? Like in case of beam, we call them stirrups. Okay. Now let's go to the stirrups over here. So there are different spacing for the stirrups at the support and the center. In the center the spacing is larger, and at the support the spacing is a slightly lesser from what we have provided at the center. Okay, and why it is so? Because we need more reinforcement at the support and less reinforcement at the center. That's why we have provided more spacing at the center and less spacing for the stirrups at the supports. Next comes, all through bars are quite clear, so I don't think there is any kind need of explanation for that. But even if you are having any need of explanation, then you can simply write that in the comment section and I will definitely explain that. Now guys, do hit the like button. Okay, next, let's go to the longitudinal section of the plinth beam over here. Okay, so in the longitudinal section of the plinth beam you will see that we have different markings over here. Like from the left end we have a distance marked at 0.1 L. From the right end at the top we have a distance marked at 0.3 L. So these are the lengths of the extra reinforcement that we have to provide in our beam. So in the beam schedule you will find that you have to provide some extra reinforcement at the start and at the end. So this is the type and the number of the bar that will be used, and in the drawing you will see the length of the bar that should be used. So for the top reinforcement we have to go for a length of 0.1 L in case of discontinuous beams, and if this beam is continuing then we will go for a length of 0.3 L. Now L is the length of the beam over here. Now at the bottom we have to provide the extra reinforcement in the center. So even in the bottom it will not go all through in case of extra reinforcement. However, the main reinforcement, that is in this case 212, will go all through. That means it will start from one end and it will go till the other end of the beam. Okay, so you can see we have two bars of 12 mm dia and it is going all through over here. Okay, then comes the extra reinforcement. This extra reinforcement from the schedule we have, for the B1 we have one bar of 12 mm dia and that will be provided at the bottom of the beam. Okay, now if we are providing something at the bottom then and it is not going all through, then there must be some kind of distance specified for this one too. So from the the dead ends, or you can say discontinuous end, we will take a distance of 0.15 L, and from the end of continuous end we will go for a distance of 0.25 L. Okay, now on the top and in the bottom there is a little difference in the measurement. So what is your observation for this? So I'm just waiting for your comments over here, and guys hit the like button because that is motivating me. Okay, so that is the only motivation that I get from this YouTube channel. Okay, whenever I come live I get a lot of viewers who are interested in learning and they are asking question over here and they are hitting the like buttons. Okay, so that is the only motivation for me over here. So do hit the like button so that I can stay motivated during this session. Okay, now if you have any kind of question you can simply ask that, and if someone is willing to answer then you can also answer, like what is the, why is there is some kind of difference at the top and the bottom. Okay, and what is that difference that you can observe from this drawing. Okay, so we will wait for just 20 seconds more to get the answer over here. So guys, you can answer what is the difference that you can notice over here from for the measurement on the top and at the bottom. What's the difference? Please answer. So by the time you are observing the answers, I will just open something for you. So we are going to organize a workshop on how to prepare the structural drawing. So this will be a 5 days workshop over here, and you can see here is the poster of the workshop, and this will be a 5 days workshop on preparation of structural drawings, where you will get to learn how you can extract the data from the Tekla Structural Designer. So all of you know that what is Tekla Structural Designer. It is clearly it is quite clear for all the viewers over here on the Civil Center channel, because we have a lot of videos on Tekla Structural Designer, how to design the buildings on that. But the problem comes when it comes to the extracting the data from the Tekla Structural Designer, and it is the actual thing that we have to go for in any designing software. We have to go ahead and find out the designing results. And guys, by the time I'm still waiting for your answers, like what have you observed? Okay, so you can simply answer that too. Okay, and if you are finding this session useful, you can hit the like button. That will motivate me a lot, so do hit the like button. Okay guys, now over here in this poster you can see we will cover three basic topics over here. And what are those topics? We will learn how you can extract the data from the Tekla Structural Designer, which is a designing software. Here you can design the four structural members of the buildings, that is the beam, column, footing and the slab. Okay, and we will learn how to observe those data. Then the second thing that we are going to learn is to how to interpolate those design results. Now the question is, why is it needed to just interpolate the design results? And the answer is because you can't use the data given by your software directly into the application. Now why it is so? Because the software will give you safe results, but it will not give you the economical results. Okay guys, so it will just take the safety factor into consideration, but from the economic point of view it is a better, it varies from the software to software. TSD will give you more economical results than ETABS or StatPro, but still we need to modify those results in order to use it practically. Okay, so even in the structural drawing you can see we don't have, I will just show you, we don't have multiple types of the columns over here, or multiple types of the planes beam or the beams. We have just 5 types of the beams on total, including the concealed beams. And when it comes to the column, we have just 5 types of the columns. But when it comes to the software, if we are having suppose 18 numbers of the columns, then you will find at least of the 9 types, different types of the columns. Okay, so that's the way the software designs the structure. But when we go for the practical application, we can't go for those many types of the columns. Why so? Because it will hard for the contractor or even the site engineer to make it happen, because the resources are limited out there. They have to limited types of the form box over there, and for the varying size you will have to go for the different types of the form box also. And if you are going for the minimum types of the columns or the beams, then it will be easy for the laborers to execute the work properly. Otherwise they may get confused and they may go for a bigger loss for your client. Okay, so that is one thing that we have to go. Okay, so Rohit Khanna is saying I want to join. Okay, if you want to join the workshop, Rohit Khanna, then you can find a link in the description. Okay, I guess this is the Jotform link that you can use. Okay, you have to just click on this link and we can go for that. And I will just explain about this also in a few minutes. Just first of all, let's understand why is this workshop important. Okay, now what is the next thing that we have to do? Next, we will when we will finalize the design results by interpolating it, then we will go for the preparation of the structural drawing. So in this live session, or you can say in this series of the live session, you are learning how to read such a structural drawing. And even if you are properly studying a structural drawing, then you can easily find a job of the site engineer. Okay, so basically the site engineer should know two basic things, or you can say the three basic things. First, he must know how to read the architectural drawing. Second, he must know how to study the structural drawing. And third, estimation is also a crucial point for the site engineers. But for the freshers, even if you just know how to read the site structural drawing, then you can find a job. Okay, now, so we have started this free series of for how to study the structural drawing. And if you want to learn how to prepare it and you know how to design any building, then you can simply learn how to prepare the structural drawing in this workshop. So this workshop is going to happen for 5 days, and it is starting from the 24th of the July, and today is 24th, so this is the last day of the registration. The timing is 7 to 8 p.m. Okay, so this will be a 1 hour workshop on a daily basis, and the software that we are going to use in this will be Tekla Structural Designer for extracting the design results. And for the like yeah, for the drafting of the same, we will use the AutoCAD. So we will also go for that one, because we need at least any software, any CAD software to draft it. So we will use the AutoCAD. So you can also you will also learn how to use that efficiently in this particular workshop. And this is just for 499 for 5 days workshop. So guys, this is a golden opportunity for all of you, and you can easily join this software training program, or you can say the workshop on preparation of the structural drawing. So how to do that? You have to simply click on this link, and this will open up a Google form for you. I guess this has already been opened up over here. So you have to fill your details over here, like the name, university, company, and email ID, contact number. Then you have to select what kind of trainee you are, what is the language preference for this workshop, and then you can simply pay the amount, and you will automatically be directed to the WhatsApp group over here. Okay, so you'll be automatically added over there, where you can like yeah, so over there you will get all the informations about the Zoom ID links, and everything will be provided to you in the WhatsApp group. And from there you can start learning the all the things in the workshop. Also you will get the recording of this workshop, so that will also be very much useful for all of you. Now let's come to our main thing that we were doing over here, that is the study of the structural drawing. Okay, so okay, Rohit Khanna is asking, in this course you will complete whole structural drawing? Yes Rohit, we will complete the whole structural drawing. Okay, so you will get to learn how to prepare such a structural drawing along with the staircase also. Okay, so a staircase is not present in this one, but you will be guided how to do that too. Okay, yeah. Next, what we have over here, yeah, let's go to the structural drawing reading. Okay, so we have covered about the longitudinal section of the beams. Now if we will just cut two different sections, one at the end, that is XX, and one at the center, that is YY, then you will see that we have got such a drawing. And over here you will find the main reinforcement at the top, main reinforcement at the bottom, and also the extra reinforcement at the top. In the bottom you will not find any kind of extra reinforcement, because we don't have any kind of extra reinforcement at the bottom in the beam. Okay, why so? Because we have to provide that in the center portion only, and at the ends we don't provide extra reinforcement at the bottom in case of beams. So this is a 250 by 350 of the beam, and 350 is the depth of the beam. The reinforcement at the top, for the main reinforcement, we have two numbers of 16 mm dia bars, which is going all through. we have two extra reinforcement of 16 dia bar, and if it is a discontinuous beam then we will go for a length of 0.1 L, and if it is a continuous beam then we will go for a length of 0.3 L. Now in case of the, and at the bottom we have this 216T also, which is same as the top one. At the YY section, okay, here is some kind of error. We have to go for 212T, okay, because in the schedule we have 212T over here. Then for the section YY, at the top you will see we have two bars of 16 mm dia that is going all through. We have two bars of 12 mm dia that is going all through at the bottom. So top and bottom bars has been explained. Now in the center we will have the extra reinforcement at the bottom, and this will be one bar of 12 mm dia. Now what is the length of this? We will leave a distance of 0.15 L from the discontinuous end and 0.25 L from the continuous ends, and whatever the distance is there in the center we will provide the reinforcement over there. Now on the top we are measuring the distance from the end where the column ends, but in this case we will just measure the distance from the center of the columns. Okay, so that is the difference for taking the measurement from in the case of beam for the extra bars. Okay, now let's see if we have any question. Okay, Shekhar Kunkel. Hi sir, hello Shekhar. How are you? If you have any kind of question you can simply ask that over here. And guys who are watching this session and finding this session useful, you can simply hit the like button over here. That will motivate me to just continue for the longer duration over here. And I am here to answer all the questions, so you can simply ask any question related to the structural drawing or structural drawing preparation, or if you have any kind of difficulty in like studying the structural drawing, you can also ask question related to that. Okay, next, so we have learned how to study the longitudinal section of the beam, how to study the cross section of the beams at the ends and at the centers. We have also learned how to study the schedule of the roof beam. So basically we can say even this typical beam column layout has been completed. So we can say we have covered the roof beam section completely in this live session, and we have also known about this workshop on preparation of a structural drawing, which is going to start today itself from 7 to 8 p.m. So if you guys are willing to register for this, then you can simply register using the link that is given in the description over here. Okay, and I will also add this in the comment section, so you can also register for this one. And this will be a 5 days workshop on preparation of the structural drawing using the Tekla Structural Designer and AutoCAD. Okay, so you can also go with this link, and this will help you a lot, okay, while learning how to prepare the structural drawing. And guys, if you want to know more about this workshop, then you can just go back a few minutes in this live session. I have explained almost everything related to this, and you are also going to get the recording of the live session, so that will not be an issue. Even if you miss the session, then you can simply just watch the recording and ask the question in the next session. Also, there will be a WhatsApp group for you where you can solve your queries anytime, even after the months after completion of this workshop. So that WhatsApp group will stay always with you, and Civil Center will always be there for you to support you in your technical fields. Okay, so guys, that was all for today. And what are we going to learn in the next live session? That we can just go for the voting. So in the next live session we are left with the two options over here. Either we can go ahead and study about the slabs, or we can go ahead and study about the foundation. So these are the two options over here that you can pick, and I will go with the maximum number of votes. So do just suggest in the comment section what you want to learn in the next live session, foundation or slab. Guys, I'm just waiting for your answers, and you just leave the comment in the comment section, and we will just go with the maximum votes. So whatever you want, just feel free to write in the comment section. And guys, if you are feeling that this session is useful for all of you, then you can hit the like button and do share it with your friends and colleagues. Okay, so just share this live session with your friends and colleagues so that they can also get to learn a lot about this structural drawing reading, and you will you along with your friends can be benefited from this. At the same time, they can also ask questions over here. And if you want to watch the previous sessions, then you can go ahead to the page of the Civil Center, and from there you can find the previous two videos. They will have the similar thumbnail like this one, and the title is also same, so it will be easy for you to find out that one. Okay, so guys, that was all for today. Go ahead and register for the workshop over here. So this 5 days workshop is waiting for you, and it is going to start today at 7 p.m. so the time is very less. You have to hurry up, make your decisions, and learn how to prepare the structural drawing. Okay guys, that was all for today. See you in the next live session. Thank you.